Good morning, everyone. Today we're going to go ahead and look at the 2.2 notes, which is about logic. Okay, our objectives will be to determine truth values of negations. Whoa, why is my pen not wanting to write? Truth values of negations, conjunctions, and disjunctions. So we'll look at those three things kind of separately here at the beginning, and then we're going to represent conjunctions and disjunctions with Venn diagrams. So Venn diagrams, that's something you're used to in your English classes likely, where you compare a couple of things and where they intersect and where they don't. So before we get started, let's make sure we're all clear here. The assignment today is page 103. And we'll do 1 through 9, and then we'll go 11 through 16. So we're just skipping number 10 there. So 1 through 9 and then 11 through 16. That's our assignment today. All right, so let's talk here. Let's kind of introduce. This is a completely new idea. You guys haven't really seen this in other places, but it is something you guys probably practice on a pretty daily basis. So a statement. Okay. So for our logic and geometry class purposes, a statement is a sentence that is either true or false. So you can make any statement as long as it's either true or false. So Mr. Hartman has 2 hands. That is a true statement. Okay, that's what a statement is. Okay, the truth value. Okay, the truth value is true T or false F. So we use T and F to represent true and false. That should be familiar for us. Okay, so let's make a couple of statements here. Obviously I made a kind of goofy one. I have 2 hands. Yes, this is true. Okay, let's make a couple statements here, maybe about some geometric things, at least for this first one. So statement P, we use P and Q a lot of times to identify statements. So statement P, let's say rectangles. Everybody's familiar with what a rectangle is. So rectangles are quadrilaterals. Spelling. Quadrilaterals. Which just means it has 4 sides. Well, do rectangles have 4 sides? They do. So the truth value of this is T. True. Rectangles do have 4 sides. So yes, they're quadrilaterals. Alright. Let's practice again. So Q. Statement Q. Humans, let's say humans have 4 legs. There's a statement. Okay. What's the truth value of this statement? Do humans have 4 legs? No, they do not. So this is the truth value of that statement is false. Okay? So we're getting the idea here. Again, a statement is either true or false, and then we can assign either T or F to it based off, well, is it true or false? Okay? So let's talk about the negation. The negation of a statement has the opposite meaning. So opposite. So let's work with these same statements P and Q and our notation here. Let me just draw it out a little clearer like I would represent it. So we use this squiggly line and then we say P. This means the negation of P or the opposite of statement P. So what would the opposite of statement P be? If we use the same statement P, the opposite of that would be rectangles are not quadrilaterals. Okay, rectangles are not quadrilaterals. And this has the opposite meaning. So what would the truth value of this be? Well, they are. So this would be false. The truth value of this statement is false. I negated something that was true, so it became false. So what if we negate Q? So statement Q was humans have 4 legs. What would the negation of that be? Humans do not. have four legs? Well, what's the truth value of this? Do humans do not have four legs? Yeah, that sounds like a true statement. Okay, so when we negate something that was originally false, the original statement, humans have four legs, that was false. When we negated it, it became true. So the truth value of a negation, it just changes the truth value when we negate it. Okay. So two or more statements joined by the word and or is what we call a compound statement. So we can put statements together by using the words and or. And implies a compound sentence that is a conjunction. We call and a conjunction. Okay. And so our symbol for if we want to use and, because guys, we use symbols a lot of in logic, we use symbols more than anything. Okay. We would say, so if we wanted to say P and Q, we use this symbol that looks somewhat like a caret. That means that symbol right there means the word and. So this is saying statement P and statement Q. And this has a truth value. Okay? When you're combining two statements, it has a true truth value. So the only way an and can be true, and you might make note of this, so and is only true if both statements are true. Okay, and only works if both statements are true. So keep that in mind as we continue here through this lesson. All right. So truth values of conjunctions. Let's look at a few examples here. So this is saying P and R. So we want to look at statement P and R. So the figure is a triangle. Is a triangle. And what's the other statement we're combining with that? R, the figure has three acute angles. Okay? So this is an and one. And remember, I said ands are only true if both statements are true. Is statement P true? Is the figure a triangle? Well, are we looking, is this a triangle? Yes, this is a triangle. Okay, so the first statement is true, if you will. Okay, when we're combining it with the next statement, the figure has three acute angles, is that true? What's the truth value of that second piece? Well, when we're looking at this specific triangle, it looks like there's a right angle here. Are right angles acute? No. So this statement's false. So when we combine a true and false, the entire thing actually becomes a false statement. And again, that's because for an and to be true, both statements have to be true. Alright, so let's look at another example. This is saying Q, this is Q, and that's not R, or the negation of R. It's got the little squiggly there in front. So let's write out what this would mean. So this would mean Q, the figure is a triangle. Use that abbreviation there. And the second part, we're negating the second statement. The figure, so how do we negate R? The figure has three acute angles, does not have, would be the negation, does not have three acute angles. So this and, is it going to be true or false? Well, the first statement, the figure is a triangle, well, yeah, we already said that was a true statement. Yeah, we look at it, it's true. And then when we negated r, well, the figure does not have 3 acute angles. That is now true. Okay? It doesn't. It has 1 right angle and 2 acute angles. So both statements are true, so the whole thing takes the truth value of a true statement. So again, and is only true if both pieces are true. Okay? So now let's talk about or. We said there's 2 truth values, okay? So let's talk about or. So let's talk about a compound sentence that uses the word or is called a disjunction. Disjunction. Okay? And our symbol, we have a symbol for that as well. We use the upside down of the and. So it kind of looks like a V. So P or Q. This is how we say or using our symbols. Okay? And you might also want to make note, okay, or is true if one statement, only one, has to be true. Okay, 2 could be true, and that would make it true, but only one has to be true to make an or true. Okay? So use the following statements to write a compound statement for each disjunction. Then find its truth value. Okay, so we're doing Q or R. So statement Q, let's write it out here. January has only 30 days, or January 1, January 1st is the first day of, to extend here, a new year. So let's think about the truth value of this whole thing. The first one, January has only 30 days, that's false. January has 31 days. So the first statement is false. Or January 1st is the first day of the new year. That second statement here is true. Okay? And again, an or, only one of them has to be true to make the whole thing true. So this whole thing, one of the statements is true. So the whole thing is considered to be true. So truth values of and or statements, they are different. Okay? The rules are different. All right? And so you guys can practice here. This one is P or Q, so pause and practice. And then practice the next one as well, not P or R. Okay? So if we're looking at P or Q, this first one, it says January is a fall month. A fall month. Or the second statement, Q, January has only 30 days. What is the truth value of both statements? First statement, January is a fall month. That's false. It's a winter month. Second statement, January has only 30 days. Well, that's false as well. So 2 falses, when we use or, 2 falses make the whole thing false. Alright? And so the last one I'll leave to you guys. We're doing not P, so we're negating P. January is not a fall month. Or January 1 is the first day of a new year. So I'll leave that one to you guys. Okay. And then let's continue. Let's talk about truth tables here. Alright, this is kind of a summary of what we've learned here. Negating something, okay, it changes the truth value. We've got the symbols over here. We use the little squiggly, and we say not P. Okay, we have conjunction, and that was again and we had the symbol P and Q, and it again read P and Q. And then disjunction, P or Q. All right. So let's practice using a truth table. So statement P is either going to be true or false. Originally, statement P it's going to be one of two things. It's going to be true or false. Okay. Well, what if we negated it? Well, if P was originally true and then I negate it, P becomes false. If P was originally false and then I negate it, it becomes true. So this is a way for you to kind of keep track of truth statements, okay? If I'm combining two statements, I'm going to have more cases, okay, so that everything matches up. And so the way you should assign values, take your first statement, make the first two cases true, the last two false. For the second statement you're using, go back and forth. So true, false, right? And then let's consider when we combine them. All right? So this is a conjunction, so this is an and. All right? So P and Q, true and true. Again, I tried to highlight this in those real examples we've already done. And is only true when both are true. So this first case, the and is true. The second case, we have true and false. Are both true? No. So the whole thing is false. Here we have false and true. So it's false. Again, both have to be trues in an and. And then we've got false and false, so of course no true at all. So it's going to be false. Okay? And then disjunction, guys, the same way, we're combining two statements, so you need to go true, true, false, false, and then true, false, true, false. And again, this is just so that we hit, these first two columns, guys, are so that we hit every case. The case that both are true, the case that we have true and false, false and true, or both false, okay? That's that's standard. We do that every time we're comparing or combining two statements. Okay, we make our four possible cases. Right? And so for an or, this is a disjunction, so for or, only one value has to be true to make the whole thing true. So we've got true and true. One value, at least one value is true, so true. True, false, one value is true, so the whole thing is true. False, true, again, one value is true, so the whole thing is true. Here we've got false and false, so no truth at all. That's going to be a false. Okay? So you can use truth tables to kind of organize what statements and their combinations might look like, okay? So that can be kind of tricky, I know. Practicing it is going to make it a lot easier here for you. So let's practice constructing a truth table for not P or Q. So I've got two statements, P and Q, so let's make those two columns here. And each time I'm comparing two statements, I'm going to have four total cases, remember. I'm going to have true, true, false, false, true, false, true, false. That's standard. Again, those first two columns kind of come for free. Should be able to get those. That knocks out all of my cases. Then what am I going to have to compare? I've got to negate P. So what would not P look like? So if I'm taking statement P and I'm negating it, well, statement P, I'm looking at this first value here, it was true. If I negate statement P, that case becomes false. Okay? If I negate a true, that becomes a false. If I negate my false, that's going to become true. If I negate my false, that's going to become true. So I've negated P. I've got a column for not P. Alright? And then my last column, it looks like I should be combining two of these statements. So what statements am I combining? Not P or Q. So this is the or symbol. So again, what makes an or true? If one is true, then the or is true. So the two columns I should be using to evaluate this are right here. Not P and Q. Or Q, excuse me. So here I've got true, false. One of them is true, so the whole thing is true. Here I've got false, false, so the whole thing is false. A couple of trues, the whole thing must be true, and a false true. Again, this is an OR, so only one has to be true. Okay, so that we've completed the truth table for this. Okay, we looked at every case we might need, right? So if you're using a Venn diagram to represent some set of data, okay, an AND is where these values intersect. So if you have statement P and statement Q and there is some overlap, then you're looking at the intersection of these. Okay, if you're looking at statements P and Q and you're thinking of an OR, well, everything that makes P true gets counted in. Everything that makes Q true gets counted in. And then everything in between is where they're both true. So everything gets counted in a union. Alright? So, let's practice here using a Venn diagram. This will be our last practice problem here. The Venn diagram shows the number of people who can or cannot attend the May or the June Spanish Club meetings. How many people can attend the May or June? So we're looking at M or June. Okay, so if we're looking at this Venn diagram, how many can do May? 5, so 5, plus how many can do June? 14, plus we've got to look at the intersection as well. Okay, so we add all of those up. How many can do May or June? 5 plus 14 is 19 plus 6. We've got 25 people could do May or June. Okay. Next one, we're looking at May and June. How many can do both? So we're looking at May and June. Okay, and again, so we're looking at the AND here. So the AND is the intersection of the two. So this is just 6 people. And then describe the meetings that the 14 people located in the non-intersecting portion of June. So what portion are we looking at? Okay, we're looking at this piece, the non-intersecting part of June. Describe the meetings that those 14 can attend. Well, what are those 14 in? They can only attend which meeting? Okay, it's not overlapping into the May piece, so these people can only attend the June meeting. They only are in the June part of my diagram, so they're only attending the June meetings. Okay, so that wraps up our practice here. Again, I reminded you guys all about the homework at the beginning, but just to kind of wrap up, again, we're looking at page 103, 1 through 9, and 11 through 16. All right, you guys have a wonderful day. Thank you for watching.